Hey, what is up, GCSE maths kids? So here is a quick introduction to quadratics. I'm going to try to make this as unfiltered and unedited a video as possible. So if this is a bit too slow for you, please feel free to watch it on a faster speed. Okay, at a faster speed even. Okay, so what is a quadratic? A quadratic is an expression that has the form ax squared plus bx plus c, and it can be written as y equals ax squared plus bx plus c, and that is the graph of this quadratic. Now you might be wondering what this graph actually looks like, and the answer is it looks something like this, where we have the x and y axes here, and then we have the graph that would look something like this. This is just an example. Now this shape is a U shape, obviously, and it's called a parabola. So that is the shape of this ax squared plus bx plus c graph. Now, hopefully you're familiar with another type of graph, the y equals mx plus c graph. Now, this is a linear graph where it'll, like that equation, is typically for a line that looks something like this, where m is the gradient. So that will be to do with how steep the graph is. So that graph is pretty steep. Let's do this in black. This line graph here is a bit more shallow. So it's not as steep as the first one. And that is all determined by the value in front of the x here. In our y equals mx plus c equation. So m is the gradient. And c in this case is our y-intercept. And that is where when we set our x to be 0, where does the graph cross the y-axis? Because when x is 0, let's do this in blue. When x is 0 here, so you have like x1, 2, 3, x minus 1, minus 2, minus 3. The midpoint is where x is 0, right? The origin of the graph. So x is 0 here. And when x is 0, where does the graph cross the y-axis? So in this case, sorry, that's for the parabola. Where does the graph cross the y-axis? So for the line graphs in this case, it's positive. So our c will be a positive number. Like this might be like +1, right? Or +2, +3. In this case, it's slightly under the origin point, so it's negative. So it might be like -2 or -3, -4, etc. So our c is just the constant, which tells us where our line graph crosses the y-axis when x equals 0. Now, our constant in our quadratic equation has the same purpose. So our c in our y equals ax squared plus bx plus c graph has the same purpose. So when x is 0, again, you're going to be left with the y value, right? So when x is 0, we're going to come to the y-axis because that is the y-axis is where x is 0. And we're going to figure out at which point this graph crosses the y-axis when x is 0. And that will be our c value, c value, c value. Yeah, so it's the exact same for the linear graph y equals mx plus c, and for the quadratic y equals ax squared plus bx plus c. Now, our quadratic graph, so hold on. So our linear graph, our y equals mx plus c, so this one here, only crosses the x-axis typically at one point, right? So it'll be this point here. What color should I do this? Let's make it green. So it'll be this point here or this point here, for example, right? And if you had like another graph that went something like this graph crosses the x-axis at this point here. So where these graphs cross the x-axis, you can figure out what that point actually is, what that x value is, by solving for x. So if you had a line graph that was something like y equals 2x plus 1, then you could figure out where this graph crossed the x-axis by solving for x, and you do that by setting y to be 0. Why? Because when the graph crosses the x-axis here, when the graph crosses the x-axis, the value of y on that line is 0. Because if you think about it, the y-axis goes horizontally, right? So this is y equals 1, y equals 2, 3, etc. And this will be y equals -1, -2, -3, etc. So y equals 0 is the x-axis, the horizontal line smack bang across the middle. So when y equals 0, so you set that to be 0 now, what is the value of x? So you want to figure out what the value of x is when y crosses when y is 0. So in this example, what we're going to do now is solve for x. So we're going to get 2x equals -1, x equals -1/2. So minus 0.5. So now this is the value of x when y is 0. So the coordinate of where this straight line graph crosses the x-axis is going to be -0.50. So this graph will actually be something like this one. Y equals 2x plus 1. So we've solved for x over here, and we know that, let's say this is -0.50, then that is the x-intercept. That's where this intercept. This is where this graph crosses the x-axis. And C here in blue is the y-intercept. So that's where this graph crosses the y-axis. In this case, our C is +1, right? So yeah, so anyway, I hope I've explained that properly for line graphs. But now we're going to figure out the x-intercepts of quadratic equations. And that would mean looking for these values here and here. So this is getting a bit too messy now, so let's just draw this again. So let's say we have a graph that looks like this, and it crosses the x-axis here and here. So this is where, let me change the color. So if we had y equals ax squared plus bx plus c, the blue is where the graph crosses the y-axis, that's the y-intercept, and we can figure that out by setting x equals 0, right? And the perfect. And we can work out the x-intercepts by doing the exact same as we did for the linear equation over here. And that is, we solved for x to work out what the x-intercept was when y equals 0. So to work out the x-intercepts, we're going to set y to be 0, and then we're going to solve for x. So that is how we work out where a quadratic equation like y equals ax squared plus bx plus c, given by this parabola here, this is how we figure out where this crosses the x-axis, right? By solving for x. Now, there are a couple of different ways of doing this based on the equation that you have. And today I want to just quickly talk about the easiest way to do it. And this is for easy quadratic equations, and you'll see what I mean by that in a bit. But let's say you had an equation that was like y equals x squared plus 4x minus 32. Yeah, let's do minus 32. So let's say you had this equation, and you were asked to figure out the x-intercept. So that is, again, where does this graph cross where does this graph cross the x-axis, right? And we're going to figure that out by solving solving this quadratic for x, also known as just solving the quadratic. So what we're going to do is we're going to set x squared plus 4x minus 32 to be 0. Yeah, because we need to set our y value to be 0. And then we can solve for x. So just as we solved for our x in our linear equation, we want to now solve for x in our quadratic equation. The thing is, it's a bit complicated because we don't just have one x, we have an x that's been raised to the power of 2. So we basically can't do the same rearranging trick, because if we try to do that here, we'd be left with x squared plus 4x equals 32. Fine, but now you have x in two places. How are you going to solve for that? So the way we solve for this is by doing one of a number of things. So there are actually 3 different ways of doing this, and I'm going to teach you, as I said, the easiest way, which is for easy quadratic equations. So this is an easy one. And this method is called factorizing. So we're going to factorize to solve the quadratic. So I'm just going to take this and paste it on the next page. Perfect. So now we want to solve this quadratic by factorizing. So we want to solve this for x, and by solving for x, we're going to figure out where this graph crosses the x-axis, right? This graph may not look exactly like this, by the way. This is just an example of a type of quadratic equation graph. We're going to solve this for x. We're going to do it by factorizing. So what that means is we are going to find 2 numbers that multiply to give our constant here. So what multiplies to give minus 32? We can't forget about the minus. So we have minus 8 times 4, minus 4 times 8, minus 16 times 2, minus 2 times 16. Is there anything else off the top of my head? No. No, I think that's all. Yeah, so these 4 sets of numbers each multiplied to give 32. Now we need to pick one of these sets, because only one of them will do, that when we add the 2 numbers together in each set, it's going to give our number in front of the x here, not the x squared, no, in front of the x. So which of these 4 sets of numbers actually add together to give 4? So if we do minus 8 plus 4, that will be minus 4. Minus 16 and 2 obviously aren't going to work. Minus 4 plus 8, or 8 minus 4 is going to be 4. So this is the set of numbers that we want. That when we multiply them together, minus 4 times minus 8 gives 32. When we add them together, minus 4 plus 8 gives 4, which is the number in front of the x. Now what we're going to do is we're going to write x plus and x plus, and we're going to fill in these numbers that we found here and here. So x plus minus 4, so that's actually just going to be x minus 4, right? And x plus positive 8. So this is our factorized expression. Yeah, so when we factorize our equation above, this is actually what we're going to get. And this is, of course, going to be equal to 0. Now I can prove that this actually, when you expand the brackets, gives rise to our original equation by just expanding the brackets. So if we had x minus 4, x plus 8, let's just expand and prove it here. When we expand the brackets, we're going to get x squared plus 8x minus 4x minus 32. So the 8x and the minus 4x simplify to give plus 4x minus 32. So this is the exact same as our equation from up here, right? So there we go. We've proved that when we factorize this expression, we get x minus 4 x minus 4 into x plus 8, and that is the actual factorized version of this quadratic, because when we expand the brackets like we do down here, we get back to our original equation, x squared plus 4x minus 32. Perfect. Now, what we have here in this factorized expression are two parts to it. We have x minus 4 and we have x plus 8, and they're multiplied together, right? There's an invisible multiplication sign between these two brackets. That's what we can't see. And in fact, we use that multiplication to expand the brackets here. So because these two parts are multiplied by each other and the total equals 0, that means that x minus 4 could equal 0 and x plus 8 could equal 0, right? So either of these expressions, either of these parts of the expression could equal 0. So now what we're going to do is we're going to solve for x in both cases by rearranging. So we're going to get x equals 4 and x equals minus 8. And here we have our two solutions. And actually, if I were to draw this graph out a bit more accurately, let's do it like so. We've got our, nope. We've got our big graph, x-axis, y-axis. The equation in question is x squared plus 4x minus 32. That's our origin point. Our solutions, we know, are x equals 4 and x equals minus 8. So this means that whatever u-shape this graph encodes for, this u-shape is going to cross the x-axis at x equals 4 and x equals minus 8. So it's going to look something like that. And the y-axis and x-axis aren't drawn to scale. But it'd be something like this. So this point is going to be minus 8, 0. Yeah, after this here. And this point is going to be 4, 0 after x equals 4, this point here. Because those are the two solutions to our quadratic. Now I said the x and y-axis aren't to scale because, of course, our constant value, the value when x equals 0, so this point here, our constant value is minus 32. So here we have 0 minus 32. So that is our y-intercept, where the graph crosses the y-axis when x is 0. Perfect. So I hope that makes a bit more sense. This is why when we solve quadratics, we typically get two solutions. And when we solve a quadratic, we are looking for the solutions. Because when we say solve an expression that's like this, what we mean is solve for x, right? In the same way, the same way we have 2x plus 1 equals 0 and we want to solve for x. When we have a quadratic, we want to solve for x. When we say solve, that's what we're solving for. But the issue is you have two different x terms. And factorizing is one of the ways we can solve this quadratic. And I'll touch upon the others in another video later. But anyway, so this is why when we solve a quadratic, we typically get two solutions, because we'll have two halves of the expression here, right? We've got x minus 4 multiplied by x plus 8. So there are two halves of the expression. In another example I did, this quadratic factorized to, I think, x minus 7, x minus 7. So in this case, these are both the exact same. And when we solve this, we're going to get x minus 7 equals 0, so therefore x equals 7. And you'll get the same on this side as well. So in this case, I forgot what that graph was. It was something like, it it was something like y equals x squared minus 14x plus 49. Yeah. So when I said solve this quadratic, I meant do this. So you can factorize it, and two things that multiply to give 49, but when added together give minus 14 are minus 7 and minus 7. And if you expand the brackets here, you're going to get this equation again. But the thing is, once you factorize it, you realize that both halves of the expression are the exact same. So therefore, they give the same solution, x equals 7. And what this means, because you only have one solution, it means that this graph is going to touch the x-axis at 7. So that will look something like that graph will look something like that. Because in this case, this graph is only touching the x-axis at one point, right? That is a situation where you only have one solution. So let's say this is 7, 0. And the y-intercept here is plus 49. So I don't have space for it, but you can picture this graph continuing and the y-axis continuing, and they probably intersect at 0, 49 further up the graph. That's gone off my page here. But yeah, perfect. So this is how we solve quadratics by factorizing. And the reason we do it is because we're trying to figure out where the quadratic crosses the x-axis. That's all we mean when we say solve the quadratic. So you set the expression to 0 by making y equals 0, and then you solve for x. And yeah, and you can solve by factorizing amongst other things. So let's just go through a couple of practice questions. So let's say you had an equation like x squared plus 2x plus 1 equals 0, and you were told to solve it. So how would we do this? So again, we're going to find two things that multiply to give 1. So in this case, 1 times 1, or minus 1 times minus 1. And when these two things add together, they have to give our the number in front of the x term here. So minus 1 plus minus 1 is going to be minus 2. And 1 plus 1 is obviously going to be 2. So that's our correct answer. So then what we're going to do is we're going to open our brackets like this, and we're going to fill in the blanks. It just so happens that both of these are positive, so it's 1 times 1, so plus 1 times plus 1. So we're going to have x plus 1 into x plus 1. And now to solve this quadratic, we're going to, now that we've factorized it, we're going to let this equal 0, and then therefore x plus 1 equals 0, x plus 1 equals 0. Obviously, they're the same expression, so therefore x equals minus 1. And this quadratic also only has one solution. So it's going to cross the x-axis at minus 1, 0. So this graph will look something like something like that. Sorry, I said cross the x-axis. I mean, it's going to touch the x-axis because there's only one point here. It's not crossing it. It's going to touch the x-axis at minus 1, 0. So let's say we now want to solve x squared plus x minus 72 equals 0. So again, what two things multiply to give minus 72? Well, we have minus 6 times 12, minus 8 times 9, minus 9 times 8. And we have minus 12 times 6. What else are we going to have? 2 times 36, minus 2 times 36, minus 36 times 2. And we want to figure out which of these pairs, when added together, gives you the number in front of the x. So there is no number in front of the x, which means really there's an invisible 1 here, right? It's not going to be 0, because if it was 0 times x, we would have no term here. This would be a zero term. So the invisible number in front of the x is a 1 because 1 times x is 1. So which of these sets of numbers, when added together, gives 1? Minus 9 plus 8 gives you -1. So 8 minus 9. 9 minus 8 gives you 1. Right? So 9 minus 8 gives you 1. So that's the correct pair of numbers. So now we're going to open our brackets and we're going to fill in our terms. So this is actually going to be -8, and this is going to be +9. So because that's a -8, we can get rid of the plus like so. So now we have x minus 8 into x plus 9 equals 0. So now x minus 8 equals 0 and x plus 9 equals 0. So therefore x equals 8 and x equals -9. So these are our two solutions. So this graph is going to cross the x-axis at 8, 0 and -9, 0. So if we had to draw it, it would look something like yeah, something like that, where this point would probably be 8, 0, the positive, and this point would be -9, 0, the negative. And of course, our y-intercept will be this point here, which will be 0, -72. Okay, perfect. Anyway, I think I'll call it a day. So that was all for this video. I hope you found it useful. And I hope you understand quadratic equations and how to solve them a bit more now than you did before. There are two other ways of solving quadratic equations, like I said, and I'll come on to those later. Anyway, that is all for this video. I hope you enjoyed it. If you did, please do give it a big thumbs up and share it with anyone else who you think might find it useful. Please do hit that subscribe button if you want to see more of the same content. And hey, let me know if there are any topics that you guys want me to cover. And I will try my best to cover them. Anyway, that is all for now. I will see you next time. Bye for now.